All right. Good morning. Welcome to day 2 of Radical Notes. All right. So today we're going to talk about rational exponents. All right. Rational, remember, means fractions. So it means we're going to have fractions as exponents. All right. Now, how did that relate to radicals? Well, in order you can convert from a rational exponent form to radical notation. All right. So x to the 5/3 is actually equal to the cube root of x to the 5th. All right. Now, how do we get that? The bottom number, the denominator, all right, that is going to be your root. And then 5, the top number, just stays as your power, your exponent. All right. So the 3, that's where this cube root comes from. And the 5 stays with x to the 5th. Now, another way of writing it, all right, there was a little typo here. But once again, we have the cube root. But notice we have the x stays there. And we just raise that whole thing to the 5th. This form right here is going to be very helpful when we start evaluating like we're going to do right now. Okay. So, in general, as we're doing something, if you have like x to, let's call it the m over n, that can be rewritten as what kind of root? The nth root of x raised to the m power. All right, that's kind of like just the general form. Whatever the bottom number is your root, this number here, the top one, that's your exponent. Okay, so if we look at number 1, before we evaluate this, let's convert it to radical form. So we have, what root's it going to be of 4? It's going to be the square root, so I don't have to write that. Now, the square root of 4 to the first power. Well, what's the square root of 4? 2. All right, there's our answer. All right, 81 to the 1/4. Well, we have 81. All right, 81. What root is it? It's the 4th root of 81 to the first power. The 1 can go here or that to the first. You don't have to write, obviously, to the first. I'm just showing you how you would rewrite it. All right, this is really just the 4th root of 81. What is the 4th root of 81? Hopefully, guys, a little better with this than you were the other day. It's equal to 3. All right, so we're just rewriting and then evaluating like we did before. All right, let's take a look at number 3. We have 3 in the bottom. We have a -8. It's okay to have a negative. Better be some odd root, which it is. All right, and I have -8, the cube root of -8 squared. All right, what is the cube root of -8? All right, well, that's -2. Then I take -2 and I square it, which is +4. So the answer is 4. Now, you could have also done -8 squared. -8 squared is 64. What's the cube root of 64? It's 4. All right, so either way works. This, by putting the exponent here, makes you deal with a little smaller numbers, which makes life a little bit easier. All right, square root of -9. Well, what's the square of -9? All right, well, that's 3i, right? Because I comes out and you get a 3i. All right, so now let's move down to 5 and 6. All right, why don't you try 5 on your own right now before I do it? All right, so for 5, you should have the cube root, y cubed, because that's where the 3 comes from, 27. Now, you can see this is where I wouldn't want to make this 27 squared in here because who knows what 27 squared is. But I'd rather put the squared on the outside. Look how much easier this is going to be. What's the cube root of 27? It's 3. What's 3 squared? 9. And there's our answer, 9. Now, negative exponents. What happens with negative exponents? We don't want negative exponents. To make them positive, this is the same thing as 1 over 4 to the 3 halves. Well, what does that mean? Well, that's 1 over the square root of 4 cubed, right? The 2 is the root, that's the square root. The 3 is the exponent. What's the square root of 4? It's 2. What is 2 cubed? 8. So you get 1/8 as your answer. All right, why don't you guys try number 7? All right, so let's see if you got it. So for 81 to -3/4, I can rewrite this as 1 over 81 to the 3/4, which is 1 over the 4th root of 81 cubed. Well, the fourth root of 81 is 3, and 3 cubed is 27. So you get 1 over 27. And there's your answer. All right. Let's try one more with 8. 1 over negative 8's in there. 3 goes there. Then all of that to the 5th power. So 3 over the cube root of negative 8 is negative 2. And then negative 2 to the 5th is 32. So it stays negative, right? Because it's an odd power. So it's negative 1 over 32 is your answer. All right. Now, scrolling down to 27 to the 1/6 times 27 to the 1/2. If you remember, when we multiply, if I multiply x cubed times x squared, what do I do with the exponents? I add them. So since the bases are the same here, this is the same thing as 27, 1/6 and 1/2. That's 1/2 is 3/6. 1 plus 3 is 4/6, which what's 4/6? It's really 2/3. So by adding these, this becomes 27 to the 2/3, which is the cubed root of 27 squared. The cube root of 27 is 3. 3 squared is 9. So this answer is 9. All right. So bases were the same. We added 1/6 plus 1/2, which actually, so you're adding these two together. We get 4/6, but 4/6 is 2/3. All right. Now with 10, you have to, what happens if I have x cubed over x squared? What do you do with the exponents? You subtract them. All right. So we divide, we subtract. Keep the bases the same. It's not 1. That still says 5. What's 3/4 minus 1/4? All right. Well, it's 2/4, right? Which is what? 1/2. So what's 5 to the 1/2? If I'm just rewriting it as a radical, it is the square root of 5. All right. And this, for these types of problems, they're going to say write your answer probably in radical notation. All right. So I wouldn't leave it as 5 to the 1/2. I would just write the square root of 5. Can't do anything with it. You're done. All right. What happens with power to a power with exponents? Well, you just multiply. All right. Well, what's 3 to the 5th? Well, 3 to the 5th, all right, is because this means the square root of 3 to the 10th, which is just 3 to the 5th, which is 243. All right, 243. All right, so for 12, we have 3 to the 1/2. What does that mean? I can't add these because 3 and 12 are different. But if I convert them to a radical, I get the square root of 3 times the square root of 12. All right, now we haven't really talked too much about multiplying radicals, but hopefully you guys remember, you just multiply the inside of them, which is 3 times 12 is 36. The square root of 36 is just 6. So 3 to the 1/2 times 12 to the 1/2 is just 6. All right. For this one, I don't know if you guys can tell. There it is, sorry. Now you can. This is a negative 1/3. So what I can do is just multiply them first. So 2, 6 to the negative 1/3 is 2 to the negative 2, right? 1/3 of 6 is 2. 1/3 of 9 is 3. To make them positive, you flip them, right? This goes up top, this goes on the bottom. So 3 cubed is 27, 2 squared is 4. There's your answer, 27 fourths. All right. This one, just distribute there. All right. So if it's multiplication, so you can do that. All right. If it was a plus, you could not do that. So the 8 times a fourth is 2. 4 times a fourth is 1. So it is x squared y is your answer. All right. Go ahead and see what you get for 15. All right. So for 15, x to the 9th times a third is x cubed. And then I get 8 to the 1/3, right? You get 8 to the 1/3. Well, 8 to the 1/3 is the cubed root of 8, which is 2. So I get x cubed over 2 is my answer. All right, for 16, I do 1/2 times 1/2, right, which is a fourth. So I get x to the 1/4. Then I get y to the negative 3/2. All right, y to negative 3/2. Now, for this particular example, okay, if I want to rewrite this in radical form, this would be the 4th root of x over, we have to move this to the bottom, which ends up giving me the square root of y cubed. Now, for right now, we're going to leave it like this. We are going to learn what we would have to do to this problem, all right, later on. But for right now, we are just going to keep it. If it says it in radical notation, this is what we want to be able to write. If it said leave it in rational exponent notation, it'd be x to the 1/4 over y to the 3/2. All right. And then last here, just to kind of summarize everything, rewriting using radicals and then writing without radicals. So take a second, think about how I can go. It goes back and forth, right? So rewrite this using radicals and rewrite this as a rational exponent. What you should have got is this. This should be the cubed root of 5 squared, which we can rewrite as the cubed root of 25. All right. Remember, it also can be the cube root of 5 squared. Means the same thing. Okay. Now, rewriting without radicals. So I'm going to rewrite this as a rational exponent. So it's going to be this 3 goes in the bottom, the 2 goes on top. So it's x to the 2/3. All right. Hope everyone understood this okay. All right. And we'll be doing practice with this soon. All right. Hope everyone has a good day and stay healthy.